Good morning students, welcome to the online course on digital signal processing. Development of online courses in MOOC as a MOOC course in CM platform, it is brainchild of MHRD India. So thanks to MHRD for this global initiative for developing online courses for benefiting the learners. I am Dr. A Revathi, working as a professor in the Department of ECE, Shastra University, Tanjavur. This course, Digital Signal Processing, it is aimed for the physics graduates of Arts and Science stream. This course has 4 credits allocated to theory and 2 credits allocated to practicals. Totally 60 lectures it is being allocated to handling theory and 60 lectures for practical sessions. This course has a first chapter which is mainly dealing with representation of discrete time signals and systems. So discrete time signals, like how to represent them, how to classify them, and how to classify them based on certain properties. Then we have discrete time systems. How to characterize the discrete time system using its impulse response, and how to find the output response of the signal if input signal and the impulse response of the system given. Then what are the properties of linear convolution, how to characterize the linear time invariant systems for causality, stability and invertibility. These are all some of the topics we will be covering in this chapter on discrete time signals and systems. This next chapter, it is on analyzing the discrete time signals in frequency domain and Z and complex transform domain. So DTFT, it is to analyze the discrete time signals in frequency domain, and in this unit we will cover the problems related to how to find discrete time Fourier transform of a discrete time signals and what are the properties of discrete time Fourier transform, and then with illustration. And next, this unit also covers Z transform, how to take Z transform of a discrete time signal with the definition on the region of convergence, what are the properties, and the proof of the properties will be dealt in this unit. Then how to solve the problems for the system or define the system with the transfer function by solving the difference equations. This next chapter, third chapter, covers the characterization of digital filters. So we have the linear phase filter, zero phase filter, FIR, IR filters, all pass filters. Then in this we have low pass, high pass, band elimination filters, how to characterize them using the characteristics of the filters. Then how to define them, then how to characterize them using the parameters phase delay and group delay in this chapter. So we will be covering characterization of digital filters in this unit in general. Next chapter, it is covering the dealing of discrete time signals, finite duration discrete time signals in frequency domain. That is by taking the DFT, discrete Fourier transform of a finite duration signal. Then we will see some problems related to finding discrete Fourier transform coefficients for a discrete time signal to represent the signal, discrete time signal in frequency domain. Then the properties of the discrete Fourier transform and the relation and the related problems for the properties of, for supplementing the properties of the discrete Fourier transform. Next chapter deals with fast Fourier transform. Fast Fourier transform that is used to compute the DFT coefficients efficiently. So here it has certain algorithms, decimation in time and decimation in frequency. These algorithms are used to compute DFT coefficients efficiently. Efficiency is measured in terms of the number of complex multiplications and number of complex additions needed to compute DFT coefficients. So this algorithm there is mainly for reducing the computational complexity and hardware complexity of implementing DFT coefficients. Next chapter deals with realization of digital filters. So in this chapter we will see the non-recursive and recursive structure, that is FIR and IIR structures for implementing FIR filter and IIR filter. Then this chapter, this is covering the design of finite impulse response digital filter. This windowing technique, it is mainly used to design linear phase FIR filter. So this FIR filters, how they are designed, what's the design procedure, and we will be covering the design of digital filter along with techniques used to design them in this chapter. Infinite impulse response digital filter, that is the last chapter of the syllabus, how to design them. What are the design procedures that can be used to design the IR filter? So this IR filter can be designed first designing analog filter and by using frequency transformation techniques to design the corresponding IIR digital filter from these analog filters. So this unit we will see the analog filters, the design first, then the digital IIR filter from this analog filter, the entirely for IIR filter design. Then the practical lab, the lab session or practical lab. This is based on Scilab. The Scilab is a tool for realizing all these experiments. So we have this is simulation experiments. So we have 10 experiments in this practical session. Out of these, 7 experiments are dealing with analysis of discrete time signals and the systems in time and transform domains. The remaining 3 experiments, they are dealing with design of FIR filters, and by plotting the man-code response, we can analyze the FIR filter performance. These are the experiments are needed to be done. The simulation experiments are needed to be done to supplement the understanding of digital signal processing course in better manner. So once this subject is studied, you may wonder where do you find applications of this subject or this course. Digital signal processing techniques can be used to analyze or can be used to deal with the real signals, real-time signals like speech, digital image, digital EEG signal, digital EMG signal, digital EEG signals. So these are digital speech and digital images can be analyzed for varieties of applications. So EEG signal, EMG and ECG signals, these digital signals can be analyzed to perform the health monitoring of the patients. So this introductory video has covered the digital signal processing subject, that is course and its associated lab experiments. Then the practical applications of this course in real time. Thank you.